So students, so now in this lecture, so we will be solving numerical number 1 on the doubly reinforced sections, right? Now the question is, the strain in compression reinforcement, for Fe415 steel and effective depth of 450 mm. Now effective depth is given to you, right? Corrected up to 4 decimal places is, take d dash by d ratio as 0.15, right? So before solving this numerical, you already know this formula, that the strain in the compression steel is given by 0.0035. In bracket you have 1 minus d dash upon xu. You already know it, right? But before solving this numerical, I would like to tell you a very important thing. Now what that important thing is, now in this numerical there is no need to calculate the force stress in the compression steel. There is no need to calculate. But I would like to tell you a very important thing, right? Because this important thing which I am going to tell you right now, it has already been asked in many examinations. It was a theoretical question. So what that important thing is, that the stress in compression steel, if it is a mild steel, it depends upon the grade of steel only, right? It depends upon the grade of steel only. Simple. It means that if it is Fe250, then the value of stress in compression steel, it depends on the grade of steel only. How much will be the value? A table will be given to you, so no need to worry about that. Clear? Now, if it is a high yield strength deformed bars like Fe415, Fe500, Fe550 and so on, if it is a HYSD bar, then the value of FSC, the stress in the compression steel, it depends upon number 1, grade of steel, and number 2, d dash by d ratio. So what is d dash? D dash is actually a distance between the center of compressive reinforcement to the uppermost compression fiber. And what is d? D is the effective depth, right? So in this question, d dash upon d is given to you, right? Why I told you this thing? Because this question has been asked in many competitive examinations, right? That the stress in compressive steel and double reinforced section depends on number 1, grade of steel only. Number 2, grade of steel as well as the grade of concrete. Number 3, grade of steel as well as the d dash by d ratio and so on, right? So for mild steel, it depends only on the grade of steel only, right? And for your HYSD bars, it depends upon the grade of steel as well as the d dash by d ratio. So I hope that you have understood the numerical, this concept. Clear? Now let us solve this numerical. It is a very straightforward numerical, right? So what will you do? Now you know this value 0.0035. You don't know how much is d dash. To determine d dash, now d is given to you, right? D is given to you. D is how much? D is 450 mm. So I can say that d dash by d, it is equals to 0.15, the ratio which is given to me. Clear? Now d dash will be equal to 0.15 small d, which will be equal to 0.15 into 450 mm, right? So it will be equal to 450 into 0.15. So 450 into 0.15, it will be equal to 67.5 mm. 67.5 mm. Clear? Now I know d dash, I know this much value. Now xu, I told you that the value of xu, it is actually equal to, that is xu maximum, xu limiting. Why? Because this formula we got when we compared the strain curve. And I told you, whenever we compare the strain curve, the similarity of triangles, what we get? We get the maximum neutral axis or the limiting neutral axis. Remember, right? So xu will be equal to 0.48d for Fe415, right? So it will be equal to 0.48. How much is d? D is equals to, the effective delta is 450. So 0.48 into 450, it comes out to be 216 mm. So xu limiting, it comes out to be 216 mm. So now what I have to do now, it is just a cakewalk. Just put the values in the formula, you will get the value of ESC. So it will be equal to 0.0035 1 minus 67.5 divided by 216. So how much the answer will be? So 1 minus, now you have 67.5 divided by 216. This is 0.6875 into 0.0035. It comes out to be 0.0024. It comes out to be 0.002406. Clear? In question, it is asking me, I have to give the answer in up to 4 decimal places, corrected up to 4 decimal places, right? So 1, 2, 3, 4, right? So 1, 2, 3, 4. Now what students have done, I have seen students, they are doing very silly mistakes. So for example, that it is in question, it is given that corrected up to 4 decimal places. So what students are doing, they are counting this also as a decimal place. So this is not a decimal place, this is a basic, you can say, primary mathematics, right? That is not a decimal place. The points or the digits after the decimal are counted as the decimal places, right? So I have seen students, let us say it is saying that up to 2 decimal places, so they will be writing 0.00, 0.0. 0.0 will not be the answer, right? So I hope that you have understood this, right? So up to 4 decimal places, 1, 2, 3, 4, the answer will be 0.0024. So it will be equal to 0.0024 will be the answer. So I hope that you have understood the numerical and it will further strengthen your concepts. So now let's move to the next numerical of the same topic, that is the W in 4 sections, and further strengthen our concepts. Thank you.